Hi everyone. So in this video, I'm gonna cover conic sections. So simply put, conic sections are cross sections of a double cone. Okay, so you can see here we have the double cone, and we have the circle. So depending on the angle of the cross section. So if you were to make an incision or slice perpendicular to the central line there, you would get the circle. You have the ellipse. You have the parabola. So we have the parabola here, and we have the hyperbola. Okay, so that's why they're called conic sections. You're taking a cross section of what we call a double cone, and also it's two-dimensional geometry from three-dimensional geometry. But in addition to just saying that they're slices of double cone, we also describe the conic sections in terms of relationships of all points to a certain point. So for example, we know what a circle looks like, but a circle is really a set of all points or locus. Okay, so I just wanted to write that here. If ever you see or hear me say locus, locus is set of all points. Okay, so set of all points x, y, such that every point on the curve is equidistant from the center. So no matter where you are on the curve, we're equidistant from the center. And what is that distance? That distance is actually r. Which means that the equation of the circle looks like this. It's the set of all x and y such that x squared plus y squared will always give you the radius squared. Okay, that's the equation of the circle. So I just want to show you in Desmos. That's what I'm going to try to do. I'm going to try to go back and forth. Okay, so I have my circle here. Yeah, just want to show you that, see, the smaller the radius, obviously, the smaller the circle, and that's what I'm doing here. So I'm changing, this is a circle with a radius of 1.4, let's say. So that's what's happening here. Okay, I'm making the radius larger. The circle is centered at the origin. That's the equation I have right here. And there's my equation of the circle. X squared plus y squared equals r squared. Okay, so that's what I'm going to do now. I'm going to go through each conic section, each equation, and then show you on Desmos. Now we have the ellipse. So in the ellipse, I'm going to see if I can draw it here. We don't have a center, but we have foci or focal points. So the ellipse is the set of all points, or the locus of points, such that, okay, so I have an animation here. Every point on the line is the sum of the distance from the two focal points is constant. Okay, so it says here, for any point on the curve, the sum of the two distances to the focal points is constant. So in this example, it's always 10. So no matter where you are on the curve, if you had to add those two lengths, you would always have 10. Okay, so I just want you to see what the conic section looks like. What are the two important points? So in the ellipse, it's the focal points. Okay, that's where the relationship is. And the equation of the ellipse is x squared over a squared plus y squared over b squared is equal to 1. Okay, that will give you the equation of any ellipse. Okay, so if we go back to Desmos, I'm gonna show you the ellipse. There's my ellipse. No, I don't have anything. There's my ellipse. Just want to show you what I'm doing here is I'm changing the value of A. Okay. So in this case, A is 7 and B is 2.4. So let's make B 3. So actually A and B, you can see here. Okay, so this is 3. Oh, I can write on this. No, I can write on it. Okay, it's okay. So A is 3 and, sorry, A is 7 and B is 3. So that's, we actually have the value of A and B, you can see right there. That's where it comes from. So you can have what we call a horizontal ellipse. So it's longer than it is taller. But if B is greater than A, then you have a vertical ellipse. Okay, so I just wanted to show you what A and B do. So A and B decide how wide, how, if it's horizontal, if it's vertical. And if A and B are the same, just want to show you what happens here. If A and B are the same, we actually have a circle. Okay, so that's what it is here. If A and B are the same, we have a circle. Okay, so that's what an ellipse is. So just again, when A is smaller than B, vertical ellipse. When A is larger than B, horizontal ellipse. Okay, we don't see them here, but the focal points are always in the same direction as orientation as the ellipse. So the focal points would be on the x-axis in this case. Okay, so let's keep going. So that's what an ellipse looks like, what its official geometric definition is, and its equation. Okay, so because we don't have a lot of time to cover this chapter, you're basically not expected to find the rule. You would have found the rule, but I at least want you to, when you see an equation, you can at least identify ellipse, circle, etc. Okay, then we have the hyperbola. So I showed you the hyperbola, that it's also a cross section, but of two cones. And basically, it's almost like you cut an ellipse and you fold it out the ends, okay? So we still have focal points, but the relationship is that every point on the curve, if you were to take the two distances, okay, so I'm going to call this D2 and I'm going to call this D1. D2 minus D1 is always constant. Okay, it's fixed. So I just wanted to show you the definition of the hyperbola. If we go back to Desmos, I want to show you that. Okay, I'll write it after. Okay. You can have hyperbola where the branches open up this way. Okay, and I just want to show you here. So when we have the values, this is what's happening. This affects the opening of the branches. Okay, this is the horizontal hyperbola. Horizontal hyperbola is equal to 1. And vertical hyperbola is equal to -1. Okay, so I'm just showing you, these are two different hyperbolas. Okay, so the hyperbola, let's write it here. We either have x squared over a squared minus y squared over b squared is equal to 1. That's the horizontal hyperbola. Or x squared over a squared minus y squared over b squared is equal to -1. And lastly, we have the parabola. So the parabola, I know you studied it as a quadratic function, but now we're looking at a parabola in terms of a conic section. So the parabola is the curve formed from all the points that are equidistant from the directrix. So the directrix is this line here. This is the directrix. And here we have the focus. This is the focus. So this is the curve that consists of all the points that are the same distance from the focus and the directrix. Okay, so I want to show you, there are 4 types. There are 4 possibilities for the parabola. Okay, so I want to show you, they're all here. You have a parabola opening upwards, parabola opening downwards, parabola opening to the left, parabola opening to the right. H and K are the vertex. So I just want to show you in one example. So H and K are the vertex. So the parabola can be shifted, but the opening stays the same. And C, let's see if I can show you. Oh, I can write, but C here, so in Desmos, they don't graph the focal point or the directrix, but the value of C, let me see if I can do it here. Well, C for 1 affects the opening, but C would be the distance between the focal point and the vertex. So in this case, C would be 1, or 4C would be 4. Okay, now I know I said that quickly. You are not responsible for finding the rules, so keep that in mind. You're responsible for at least recognizing the opening. So the way I remember that if it's x squared, it's either up or down, because we know y is equal to x squared is the basic quadratic formula. So anything x squared is up or down. Y squared is left or right. Positive is up, negative C down, positive right, negative left. Okay, so I just want to, for example, if I had x minus 4 squared is equal to -16 y minus 2. There we go. Okay, parabola is opening. Oh, why did I do that? No. Parabola is opening downwards. Okay, downwards. Because this is negative. The only thing we can see really from the parameters is the vertex. So the vertex here should be 4 and 2. Exactly. H and K. Okay, so I just wanted to just give you a quick summary. So this I actually got from Math Help Services. So these are the 4 possible equations for the parabola. Again, you're not really going to be working with the rules. We're not really finding the rules. You're actually only going to be finding intersections between conic sections and lines, or conic sections and conic sections. Okay, so hopefully this helped in terms of you visualizing what the conic sections look like, and maybe just a quick recap. So circle Circle looks like this, where this is the radius. Ellipse, okay, I'll only draw one version. This is what the ellipse looks like, where, I forgot to maybe say it, where this is actually A and this is B, that's the ellipse. Hyperbola, there are two equal to 1, always a subtraction, or equal to -1. So 1 would open like this. Your focal points are here. Oh, I forgot focal points for ellipse would be there. And -1 opens this way with the focal points there. And parabola, I'm not going to rewrite them all. They were right here. Okay, these are the 4 possible equations for the parabola.